today, the second part of the Stats 1 notes is going to be talking about what are called box plots or box and whisker plots. Okay. Now, they're a convenient way to graphically depict a 5-number summary of data. The 5 numbers include a minimum, 3 quartiles, so you have the quartile, first quartile, second quartile, third quartile, and then the maximum value. Okay. Quartiles is what splits the data into 4 quarters. Right? So you have 3 quartiles, that splits it into 4 quarters. Quartile 2 is what's called the median, the middle number. So remember to find the median. Remember back to what you should have done hopefully in middle school. You should have done mean, median, and mode. Median is the middle number, so you're going to have to write them out, and you're going to have to count in and find the middle. Okay? So now, if it's for the median, if there's an odd number of data pieces, you just find the one that's in the middle. So if there's 13 pieces of data, that's pretty easy. You go 6 on each side, and then that 7th one from each direction will be the middle, right? Now, if it's even, then you have to take the middle 2 and average them. So if there's 10 pieces of data, you count 5 in on each side, and you take those 2 numbers and you average those 2, right? So remember to average them, you add them up, divide by 2. Okay, so that's how you're going to find the median, which will be quartile 2. So here's how you find those quartiles, where we just kind of talked about it. So you list the values from least to greatest. Okay, this will also allow you to easily see the min and max. Okay, then you find the middle value. That's what we just talked about, the median. Okay, if there's 2 middle values, meaning if there's an even number of data points, then you average the 2 middles. Quartile 1 is the middle of the data below the second quartile. So it's the middle of the lower half of the data. Quartile 3 is the middle of the upper half of the data. The interquartile range. Okay, this represents the spread of the middle 50% of the data. So to find the interquartile range, you do Q3 minus Q1. All right, an outlier. So an outlier is a piece of data that falls way out of the range, way out of the grouping of data. Okay? So you can either have an outlier that's too low or too high. So to find your outliers, what you need to do is find the lower bound. Okay, to find out what the lower limit for the outliers is going to be, you use this formula right here. You take the first quartile, subtract 1.5 times your IQR, your interquartile range. Okay, it'll tell you the lower limit. So anything below this value will be an outlier. To find in the upper limit, you do Q3 plus 1.5 times the IQR. Okay, that'll tell you anything higher than that number will be an outlier on the top end. Okay? So it's possible you could have no outliers. If all your data falls within those ranges, then you're fine. There's no outliers. You could have more than one outlier. Okay? Especially when you have real big data sets. Okay? You could have a whole bunch of data that's really packed in tight and pretty, well distributed or real closely distributed. And then you could have a couple that are way out on each end. Okay? So now, the first example is we're going to talk about how do we read this. So this is a box and whisker plot or box plot. Identify the outliers, the min, the max, Q1, Q2, Q3. Now, the min and the max can be outliers. So what are the outliers here? The two that are not part of the box and whisker. Okay, these two asterisks. Yeah. So 0 and 2 are the outliers. Okay, what's the min? The outliers can be your mins and maxes, yep. So the min would be 0. Okay, what would the max be? Yep. This value here, the end of this. Q1. So you find Q1 by going right here, whatever that is. So approximate, what do you think that is? 4.5, 4.7, it's bigger than 4.5, so about 4.7, 4.6, somewhere in there. Yep, it's an approximation. You get 4.75, you get 4.6, those would all be acceptable. What would Q2 be?
4.
Careful, Q2 is, this is Q1 here. Q2 is in the middle line there, so it'd be what? Somewhere in there, 5.5, 5.6, something like that. No. Any of those would be acceptable. Okay, and then Q3. Okay, so that's what you can say about this. The other thing you can look at too is, look how much distance there is between the median here, Q2, and then all this data down here. And look how short this distance is. So what that means is there's a lot of data that's packed up here, but it's really spread out down here. So it's really closely situated between Q2 and the end, the upper, the maximum, right? Because that's only what? 1.5 to 7. Okay, versus this lower end is really spread out. Okay? Does that make sense? It's one way you can visually see what's going on with the data using a box plot. Okay? All right. Now we're going to work on making ours. So what I'm going to do, example 8. First thing, I'm going to write this in order. Find the min, max, and quartiles. I'm going to rewrite this. So what's the smallest number we have here? 4. Then what? 17. How many times? You got to write it out every time, right? So we got 4. We got a 17 there. We got a 17 here. So it'll be that one. Got another one there. 17. 2 18s. 20. 2 21s. 22. And then the 50. So it says find the max, min, and quartiles. So the min is what? Max is, let's see, Q2. So how many pieces of data do I have here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, right? Just double checked or recounted them after I wrote them, make sure I had the right amount. I have 11 in the original, 11 there. So in the middle is what? Yeah, I'm going to have to count 5 in from each direction, and then that'll leave me a middle number. Right? So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So this middle number is this 18 right there. Okay. So I find Q1 first. I need Q2 first. Then I can find Q1 and Q3. So now I need to take Q1. So it is the middle or the median of the lower half of this data. So there's 5 values below that. So the middle of that is 17. Q3. There's 5 units, 5 pieces of data there. So 2, 2, so 21 is the middle there. So remember, what's my formula for the IQR? Q3 minus Q1. So it's going to be what? 21 minus 17. So your IQR is 4. Now we need to determine if there are any outliers. So to find my minimum, so this is where we have to use the formula Q1 minus 1.5 times the IQR. Q1 is 17 minus 1.5 times the IQR, which is 4. So 1.5 times 4. So 1 times 4 would just be 4, and then half of 4 is 2. So this is going to end up being what? 17 minus 6. So that's going to be 11. So do I have any minimums that are outliers that are on the small or on the low end? So anything less than this number would be an outlier. So 11. Are there any values in this data that are less than 11? Yeah. So we have an outlier of what? I got 4. Now I need to find my maximum. So what's my maximum then? Well, we do Q3 plus 1.5 times the IQR. So Q3 is 21 plus 1.5 times 4. Well, that's 6, right? So it's going to be 21 plus 6. 27. So do I have any values that are greater than 27? Yeah. 50. So I have 2 outliers here, 4 and 50. Okay? So at 4, every time we have an outlier, we're going to put a asterisk there, an asterisk there. Okay. Now to make the box part of our box and whisker plot, we need Q1, Q2, Q3. Q1 is 17. So I make a vertical line there. Q2 is 18. Vertical line there. Q3 is 21. So make a vertical line there. Okay, now what I'm going to do is mark out where I need to draw my whiskers to, or those lines. So it's the highest number that is not an outlier. So what's the highest number that's not an outlier? 22. What's the smallest number that's not an outlier for the other one? Well, guess what? 17 is my what? Q1. So I don't have a line going there. Okay? All right. my box plot or box and whisker plot for that set of data. Now, what interval represents 50% of the data? So if we look back at the notes here, which interval represents the middle 50% of the data? That's the what? Interquartile range from what? Q1 to Q3. So this is going to be the interval that represents it is going to be 17 to what? 21. So you can either write it in interval notation, or you can just say 17 to 21. Can you find the mode from the box plot? If they just gave you the box plot, could you determine the mode? Can you figure out the most frequently occurring number from a box plot? No. If you didn't know the set of data, you couldn't. Right? So no, you cannot find the mode. Remember, the mode is the most frequently occurring set of data, or piece of data. Median. Can you find the median from the box plot? Yes. It's whatever Q2 is, right? So what is it in this case? 18. Can the mean be found from the box plot? If so, what is it? If you didn't, from just the box plot, if you didn't have the data set, then no, you can't find the mean from that, right? Now, since we knew the data on this one, we could find the mean. We could also find the mode, right, if you know the data. But if you're just looking at the box plot or box and whisker plot, you cannot determine that. Okay? So additional practice is analyzing histograms, so stuff we did before. Go ahead and see if you can answer these right now on your own. See if you can read this table based off what we did with histograms the other day, and see if you can analyze this, okay? All right, what's the total number of people in the sample, and how did we come up with it? 15. What did you count? Okay, so each frequency, right, for each interval. So the interval from 27 to 35 has 2, right? 35 to 44 has 3. 45 to 53 has 5. Then 2, then 1, then 2. And you add those all up, right? Can we say that the mode is in the interval from 45 to 53? You have to be very careful with this. The mode is the most frequently occurring individual set of data. Yeah, because that is from 45 to 53, right? Yep. Okay, generally the mode is one number, right? This is an interval, so you could have, 1 at 45, 1 at 46, 1 at 47, 1 at 48, 1 at 49. But then in the 35 to 44, all three of them could be 40, right? And that would be the mode. So you cannot necessarily say that the mode is in that interval because we don't know. That interval is too large to be able to say that, right? There could be some times where you could say it, like let's say the interval was only 2 units wide, and it was more than, whatever double of any of the other ones. Let's say it was only like 39 and 40, and there were 6 of them there, and then the other one, all the other ones had like 2. Well, that would have been one of them that could have been 3 or, more, and for one of those ages, and then that would have been more than any of the rest, right? So you can't always say no, you can't, but In this one, we cannot definitively say that the mode is in that interval. In which interval does the median fall in this sample? So what would the middle number of the data be? Well, think about this. There's 5 of them here, right? And there's 5 of them here, so where's the middle number got to be? In there, right? Does that make sense? So the median falls 45 to 53. Which of the following statements are true? Most had an HDL of 45. Of 45? I can't tell, right? Could be, could only have one at 45, and then everyone else could have, 46, 47, 48, 49, etc. So is this true? No, it's false. Okay, or the questions I like more are definitely not, maybe, or definitely sure. Because, like, there's some things that, could it be? Yeah. Well, does it have to be false? No. But does it have to be true? No. Okay, it could be. But we can't say it's true because it's not definitive. More than half of the samples were below an HDL of 54. Is that true or false? It's true. How many samples are below an HDL of 54? Well, it's all these, right? There were an equal amount of HDL from 54 to 80 as there were from 45 to 53. From 54 to 80, there's how many? 5. And from 45 to 53, there's what? 5. Okay. There were more with an HDL from 27 to 44 than from 54 to 80. They're equal, right? From 27 to 44, there's what? From 54 to 80, there's what? There's not more, they're equal. Make sense? Alright, so let's look at some examples in the practice. So we'll do another box and whisker first, then we'll go back and look at a histogram like we did on last week. Let's get out the practice, the Stats 1 worksheet. Alright, so it looks like this. So we are going to go to number 2 here. Use the data to complete and create the following. We're looking at number 2. So create a dot plot. Well, that's what we did last week, so we're going to make a dot plot. So what do I need to go, what does my data have to go from what to what? 0 to 19. Okay, so I'm going to draw a line in there. Alright. Now we're going to make my dot plot. So remember, a dot plot just is like a frequency, just tells me how many times. Okay, so look at this one, 4. So I put a dot, 4, 0, 4, 7. So go ahead and finish your dot plot off. Okay, so your dot plot should look something like this. There's 25 total, right? The easiest way to do that is look at this table. It's a 5 by 5. So it means 25 total pieces of data. So now it says find the min, max, and quartiles. So see if you can find the min, max, and quartiles of this. Everybody know how to do that from a dot plot? Make sure when you count, though, you count. If you count one direction, you count them all the same way. If you count the other direction, you count the opposite way. Meaning, like if I'm counting from left to right, I start at the bottom and go, bottom up for everyone. If I start at the right, I'm going to go top down. Okay? It only really matters if you intersect at the same value. You know. Alright, so Q2. There's 25 total, so it means I gotta count what? Well, half of 25 would be 12.5, right? So I'm gonna count 12 in from each side. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the 13th one's going to be in the middle. Now what I said by counting the opposite direction, when I count these, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay? Because I counted these from the bottom up. When I go this way, I'm counting from the top down. So I make sure I get the right. Okay? It's not necessarily going to matter in this case, but it could, possibly, depending. Alright? So, 7 is Q2. So now the question, what if Q1 and it doesn't exist? Well, it actually does, because there's 12 pieces of data down here, right? So if there's an even number, you got to count to the middle and find the average. So 1, 2, 3, 4, 5, 6. And start on the other one. 1, 2, 3, 4, 5, 6. So where is, it's going to be right in the middle there, right? So it's right in between 3 and 4. So that's when you have to average 3 and 4. Because it'd be right here, right? So it's going to be 3.5. So you add 3 and 4 and divide by 2. Because it falls right in between those two. So that's going to end up being 3.5. Q2, or Q3, excuse me, I already found Q2. Q3, do the same thing, just go on the other side. So I'm going to count here, 1, 2, 3, 4, 5, 6. So 6 takes me to right here, right? This point. Now I go this way, 1, 2, 3, 4, 5, 6. So it's in the middle of 10 and 10. So what's in the middle of 10 and 10? 10. If you average 10 and 10 together, you get what? 10. Right? Alright, so find the IQR. So how do I find the IQR? Q3 minus Q1, so it's going to be 10 minus 3.5, so that's 6.5. So to find outliers, what do I need to do? So you're going to do 1.5 times the IQR, and then you're going to take and do what? Q1 minus the 1.5 times the IQR. This is going to tell us our lower limit. So our lower is going to be what? Q1 is 3.5 minus 1.5 times 6.5. So let's see, half of 6.5 is 3.25. And add that to the 6.5, so it's going to be what, 9.75? So 3.5 minus 9.75 is 6.25. So do I have any negative values here? No. So does that mean that there is a outlier on the low end? No, there's no outlier on the lower end. Now to find my upper limit for the outliers, we do Q3 plus 1.5 times IQR. Well, we already know what 1.5 times IQR is, right? 7 or 9.75. So I add that to what? 10. So I get 19.75. So is there any outliers above that? No. So that means there's what? No outliers. Create a box plot. Right. Let's see if I can grab this here. So bring this down. Values I need on it. And there. All right. So my box plot. I start with Q1, Q2, and Q3 and make vertical lines there. Q1 is at 3.5. Right in the middle there. Q2 is at 7. Q3 is at 10. There's my box. And my whiskers go where? 0, and then what? Way out to 19. Okay? So there's your box plot for that. A box and whisker plot, however you want to say it. Alright, now, question down below. Within which interval does 50% of the data fall? %, remember, is between what? We say in the notes. Look back if you need it. Try QR, which so that's from what? Between Q1 and Q3. So it's going to be what? 6.5 to 10. Right? That's Q1, that's Q3. Remember, your quartiles is divided into quarters, right? So the middle 50% of your data falls between Q1 and Q3. So that's a box and whisker plot.